Hello.
Good morning.
How are you?
Good. It's a very dark day. Okay.
Oh,
Interesting.
there we go.
Yeah. It's it must be very gray and cloudy out.
Yeah.
got a few bits of news.
All right. All right. I don't know if Morgan had anything he wanted to update us on now, or
Well, and sure. Just because well, yeah, this is an interesting initiative. So MedArc, I guess medarc.ai, if you want to find the website, is relaunching. So this was an open science effort to have I'm not sure, well, yeah, just an open science effort towards which focused on both real time and and uh, and a normal. I don't know what the opposite is to actually call it, but using the natural scenes data set. This is an fMRI data set of a large collection of images shown to subject in the scanner. And then the real-time version of it as well as an offline, I guess would be the way to call it. And the output of last round was popularized by its title, Mind's Eye, and I think Mind's Eye 2. So they have relaunched. This was, and if you remember this, Bradley, this was employees. I mean, technically, these were employees of Stability AI.
okay.
Right? Yes. So I think part of the relaunch is that they left Stability AI.
Yeah.
Together with perhaps a lot of other people.
Yeah.
Or Stability AI pivoted. Depending on who you ask.
Right.
But they have a new company called Sophont, Sophont AI, of course, because if you want to get funding these days, you've got to use those two letters. And there's three initiatives so far, and then a fourth one coming. So they are relaunching. They're not calling it. They're yeah. Perhaps for legal reasons, they're not using that name. But they're calling it Foundation FM or something. You know, like no fMRI FM. That's it.
Okay.
Sorry. Of course, the FM being the foundation, and real time or like yeah, it's the second project is real time FM, and then the third is Path FM, which is pathology. So it's you know, again, there's some reason there is a connection to this and kind of psychiatric neuroimaging. I know several groups that have wanted to use neurofeedback in in the scanner, basically, right? And which gives you an interesting way to kind of confirm that your protocol is actually making a brain change, right? That is different than what has traditionally been done using essentially what they call QEEG, which is a kind of strange derivative of EEG. It focuses on certain frequency bands changes in EEG, and it hasn't really been shown to be. It has a lot of controversy around it in terms of its reliability and its effectiveness in changing, and being able to affect change long term, right? So doing this in the scanner is one way of trying to see, like, can you, with a learning paradigm, change your brain activity, right? At least that would be the reason for engaging in this, right? Whether that brain change is also effective in some sort of symptom management, or etc., is a second question, right? So it's just like making that change, and then having that change be on whatever, say depression metrics or other things like that, is the second question. And then what they're doing with pathology isn't so interesting, so I attended all three meetings in terms of the presentations that they covered. Again, there's a lot of overlap with previous software efforts around real-time fMRI that were interesting to me in terms of what approach they were going to take. I've been doing stuff in the scanner since the late 90s, which just means that I'm old. But because we were doing EEG in the magnet. So the issues that you have in terms of being able to, how to get real-time data from the scanner, how to synchronize with the timing of the scanner, how to deal with artifacts from the scanner, artifacts being a more EEG related thing than real-time fMRI. But some of those are interesting, and then the application of foundation models, which just means a pre-trained model. Yeah. Application of a pre-trained model is interesting as well, because again, a lot of the problems that you have relate to how to do analysis that is traditionally done offline in some expedited way, meaning that they don't do full pipeline, they do some partial pipeline to get a real-time result, right? Mm-hmm. So these were all issues that I was very familiar with, was interested to see what approach they would take, and also relate back to some work that I'm hoping to do back in my hometown, which is Roanoke, Virginia, which was one of the sites that actually pioneered real-time fMRI, especially as it relates to computational psychiatry. So these are people doing gambling tasks and other things, like in the scanner, or even hyperscanning, but again in the scanner, between two scanners, one in Blacksburg, one in Roanoke. And like even back in 2014, they were doing GPU, using GPUs to do the real-time processing to give you those analysis, those typically offline analysis. But so that was interesting. The Path FM project, is currently being used on what I would call more kind of oncology data sets, in the sense, but I'm again really interested, because in psychiatry there's also a subfield that focuses on post-mortem analysis of brain tissue, and looking, yeah. So I'm interested to see how much these, what they're calling pathology models, you know, can be used, again, how these pre-trained models can be used to help us distinguish or identify tissue differences from postmortem brains. And the Lieber Institute for Brain Research is a center at Hopkins that has the largest collection of postmortem schizophrenia brains. So I think they've got like 4,000 or something like that.
Wow.
I mean, a big collection, and again, really interested to see, how tissue models get trained and how they can potentially be used to augment this kind of brain analysis. So there's a fourth project that they're starting that's called that is definitely medical reasoning. I'm not sure what the code name for it is, but yeah, I think that reflects that Safon does have some sort of business plan. So I'm not sure exactly what that is, but I assume it's like, let's take some sort of large reasoning model and give it a medical purpose. But so I like this project, well, two things. One, this project is a real open science effort, right? Like this was one of those projects where they said like, hey, we're gonna have a Discord. If you want to get involved, like join the Discord, come to the meetings, pick a task and dive in, and like this is open, and it was very much a open project. So I think it was very innovative that way, or it really did break some molds, right?
Yeah.
And two, because I kind of want to relate this to the EEG challenge that is part of NeurIPS, which again, by the way, if I haven't talked about this before, the EEG challenge that NeurIPS is doing is using a large psychiatric data set. So I'm this is my favorite Child Mind Institute Healthy Brain Network data set. I've talked about it for a long time because I think it's awesome, and I'm glad that somebody, well, it's not just somebody, it's the guys. This is the PI who runs NeurotechX's MOAB project, the mother of all BCF benchmarks, is actually leading this effort. So it's like, yeah, we used this for a hackathon a couple of years ago. It's great to see it's being used for NeurIPS. It's great to see that they got so much interest. They got 450 groups that have already signed up, that it overwhelmed their competition infrastructure. So they had to push back the start to Monday. Okay. But there is a part of medARG that is using that has some people that I know that tried to do transfer learning from mind's eye to EEG. Now this comes back to some issues that I have about in terms of just like it's all fine and dandy that we agree, sort of agree what foundation models are. But in general, like the only data set that we have that's kind of foundation model size is like taking all of the internet's text, right? the question of whether there's any fMRI data set that comes close to that is a big one. And so this is also interesting and important in terms of just like what data sets are they training to use, and then how are they testing this? And so this is also pretty. So again, I'm interested in following this because they have resources. Like it's an open science group, but it's an open science group that has resources that I find to be beyond most groups.
Okay.
And one of those is that they got access to the UK Biobank. Now, getting access to the UK Biobank, you got to understand that there's been some serious controversy about this. UK Biobank pulled everyone's access. I forget exactly when. I don't know if it was earlier this year or even before that. But basically, UK Biobank said, like, hey, nobody can download the data anymore. You got to use our cloud to process the data. But everybody was actually really annoyed and were saying that this actually restricted their ability to even process the data the way they wanted to. So again, there's some really interesting things that are involved in this. The next data set that they want to add is one that I've not been able to get access to, which is the NIMH's ABCD. and so on Monday, excuse me, the ReproNIM ABCD training program begins. and I would really like to be involved. It's interesting both to see again the additional containerization of all kind of processing in terms of how that's done. We've talked about some of these things, or I think Stefan Bollman is one of the best people doing this kind of work and trying to kind of collect technologies from scaled web services and things like that to apply to this. Again, it's really important. When you want to, again, like try to do, start to deal with data sets that like there's no, you don't even think about trying to download this to your laptop kind of thing. So anyway, I just think that there's a whole lot of things interesting about this, and kind of want to think about, or I'm following these projects because I think there's a lot that we can learn in terms of how to do science these days, in terms of the data set sizes that we need to make real psychiatric translational work possible. But it's tied up with data access issues, it's tied up with compute access issues. And how to really leverage all the machine learning that's been going on in terms of their path work is built on Dino 3. So and Mind's Eye is also taking, again, like their work from Stability AI was not they learned a lot at Stability in terms about scaling and in terms about self-supervised approaches, so yeah, anyway, I don't want to go on too long about it, but I thought that it's really interesting to follow, and would like to make regular updates about it in terms of just tracking this progress as part of, I'm really trying to connect this to what I've been calling computational psychiatry, and we'll be talking more about trying to get access to the Lieber Institute's data sets and see, like, it's not Sophon's interest, but like doing that kind of postmortem tissue analysis with these pathology models, I think is another interesting thing to talk about, and it kind of relates to some work that in a project called Big Brain. So again, Big Brain being kind of a successor to the European Brain Project. So, all right.
Well, yeah, that's great stuff. Yeah, I'm interested in following up on a number of these things. Yeah, we never really did follow up on the containerization stuff. I mean, I guess I don't know what more there is to say or what the next steps are there. I mean, do you have thoughts on that?
Yeah, I mean, for sure. So we part of a group called Connection that's doing that's training radiologists and neuro researchers in Africa. So it's part of this kind of it's also dealing with the compute and bandwidth issues that that some countries have. And so I was super glad to see that they were using NeuroDesk, both from a training standpoint, from the Oxford does a course on their software, right? They insist that you show up to workstations that are have all the software pre-installed, right? Because like you're going to do a 5-day course, and they can't have everybody just bring their own laptops and then see if we can get it installed, sort of thing. That'll take your 5 days, right? So NeuroDesk is great in that regard, but then it's running it as a multi-user cloud Kubernetes project is really where you can see NeuroDesk as a kind of container or orchestration tool that is when coupled with the right backend infrastructure is just what your system admin would want. So I'm kind of working with an old friend of mine who's been a back-end data engineer for kind of an ops engineer for big companies for a long time, just in terms of playing with that and seeing how to get that running on cloud infrastructure and how to get that running inexpensively too. So I2C2 I2C2.org is an org set up to run these kinds of things for nonprofits, for instance. So it's like I'm trying to set up a kind of neurodesk.neurotechx.org, so that I can because it's not only a problem for teaching a course, it's a problem just in general, right? Yeah. But I was thinking about this, like since I got in touch with Stefan to ask him, because Google Cloud made a change that kind of killed NeuroDesk on GCP. Oh, okay. And so that's fine in the sense that actually a lot of the IBM Cloud, Oracle Clouds kind of offer bigger bangs for your buck, especially, and those are actually services that are more likely to give you cloud credits if you are a nonprofit or you make a kind of science request for them. So it's not so bad, but I was reaching out to him and then was thinking hey, have we started planning for the the applied active inference meeting? Yeah. And was there something that you wanted to do for that in terms of maybe we could reach out to Yarrick again, if we get in touch with Yarrick earlier, because again, like it's not just his work at NeuroDebian, it's his work at the Center for Reproducible Neuroscience. And I mean, it's not, I shouldn't say it's just Yarrick, or, reaching out to David Kennedy, because I think he's the person behind that. And yeah, anyway, it's definitely it's like in terms of any cloud, running things in the cloud these days, like it's an essential technology, right?
Yeah. Well, I'll talk about the active inference stuff in a minute, but I guess, it's all the questions I had. I think this is interesting, the stability AI genealogy that's forming. So these people just ended up in different places, and there's a successor organization, you said.
Yeah. So the young kid who definitely started MedArc has had no problem, I think, raising with taking this kind of like MedArc team and raising for Softened, what they call Softened. And it's also, I don't mean to take this over as kind of a neurotech, or but this also relates to a company that I visited over Deep Tech Week here in San Francisco, called AllJoined. And so AllJoined is an EEG version of MedArc, and so yeah, I know that there's some relationship in terms of these are either all former stability people, or these are kind of like they've got a MedArc pedigree together or something like that. But again, it's these are people who've been seeing, again, like what pre-training and having the right metrics to see scaling behavior that leads them to believe that certain things are doable, right? and that's the bit that I'm trying to, like again, like there are for as dystopian as Silicon Valley has become, I don't want it to get lost that there are some technical breakthroughs, or there's some technical work going on that's really important to follow and to understand, right, as it relates to model training and things like that. And I would say that I think the paper, coming back to kind of the containerization and things like that, like one of the reasons that I think I put you in touch with Yarrick first for the Institute's conference was his arXiv paper called PsyOps, not spelled PSY,
No.
but spelled SCI, which I think is interesting that it could be either.
Yes.
I didn't until I said it out loud.
Yeah.
If I just read it, it's fine. But when I said it out loud, I thought that was pretty funny, and I'm sure that Yarrick knows that. Yeah. It's a great, or like it's an interesting paper that absolutely relates to topics that we would want to cover.
Okay. Yeah, that's great. Well, that's a great update. So you've been up to quite a bit. A lot of things to follow up on.
Yeah, that was good. Just trying to think if there's any. We're doing a BioViz hackathon. In terms of fabrication, the microelectrode arrays, open eFIS platform work, yeah, like we'll be doing some meetings next week to try and, students are coming back. I met with the UIUC NeurotechX group.
Okay.
They've got some questions about becoming a nonprofit.
Yeah.
They are finding it difficult. The university takes their money. I mean, when they receive money, the university takes it, and then they find it very difficult to get back from the university.
Right.
I didn't know whether to put like if you had any thoughts or guidance for them on that.
Oh, it's typical university bureaucracy.
Yeah. So they are very interested in becoming independent.
Yeah.
And so that was a nice conversation, just as it relates to, like what the NeurotechX board needs to consider about, like, again, like how to structure the organization to help the students, right? So it's like, if we could be a fiscal sponsor for these orgs, in some sort of responsible, not open ourselves up to liability or anything, but it's if there's some way that we can structure the org that would be useful, I think that would be really valuable. Want to talk next week about mind in vitro with the students coming back and where we are with that, and our approach to, have you seen this new paper from Brett Kagan? Sorry, let me. It's actually a great overview of kind of two approaches to what you might call synthetic intelligence work.
Okay.
Actually, figure 1 and 2, they're both great.
Yeah, this is Two Roads Diverged: Pathways Towards Harnessing Intelligence in Neural Cell Cultures. It's Brett Kagan is the sole author. And
and he's the chief scientist at Cortical Labs.
Okay. So this is figure 1. This is organoid intelligence and bioengineered intelligence.
Yeah.
So they're making the distinction between, like, just kind of normal bioengineered tissue and organoid.
Right. Okay. Right. So which is So these have these are very different engineering choice, right?
Right.
Where one is using these developmental signals to both induce the differentiation, as well as to allow the cells to self-assemble, right? Mm-hmm. I mean, it's this that's the organoid culture, which you can. I mean, again, like a lot of the organoid researchers focus on how to guide that process to desired end targets, right?
Right.
So a number of number of great groups that work on this, and they want to kind of recreate in this organoid way particular tissue targets of normal brain, right?
Right.
And then the bioengineered approach is very different, and scroll down to figure 2 there, in terms of these two pathways, right? So, and that I think is really gets at, like, what we've been trying to do with 3D bioprinting, right? In terms of linking this perhaps more traditional bioengineering approach to structure, to tissue engineering.
Yeah.
Right. And I think so. It was it was nice to see this from Kagan. In talking about this second path, that because a lot of people, I mean, as you know, I've been really interested in following organoid work. We both had to make a choice in terms of, can we do we have the infrastructure for organoid work, and do we have the funding for organoid work?
Right.
But the main thing being that there's also a very wide, or big disconnect between our ability to generate these organoids and our ability to simulate what we will get. Or like the complexity that's there,
Right.
and that's one of the reasons to follow these like virtual tissue groups, sort of like James Glazier in Indiana. That second path, of bioengineered intelligence, not everybody involved in this work is super happy with that particular name.
Yeah.
but again, I like that Kagan's made the distinction, and
Right.
because it does relate more to the approach that we're hoping to do with kind of like building up with the mind in vitro, because it started as a 2D neuronal culture.
Right.
Are there simpler ways that we can use, again, very inexpensive consumer hardware that's been repurposed, simple cell culture work, instead of kind of like the reagents and other things needed for the organoid culture, that allow us to do these engineered cultures. And so these are more reliable, kind of like, we print, this is what we want to call is 4D bioprinting,
Right.
where we print in 3D, but then we get some growth, but we don't need to do this massive quality control where we kind of go through all of our organoid cultures and decide which small subset of those are actually like our tissue targets, right? It somewhat reminds me of LLM complexity, in the sense that, like, with LLM training, you get this thing that's not really, you don't really understand it, and it's not fully under your control. But then you kind of you try all these all these fine tunings to sort of guardrail it into the thing that you're testing for,
Right.
and so I thought this was a nice overview paper for an alternative approach, and one that is also appealing to us because it's less expensive.
Right.
But again, it's super important in terms. It's not just that it's less expensive. It's although that does make it more accessible, but that, again, we would love this to be a undergraduate um, accessible project.
Yeah.
Yeah.
So I find this figure, well, 2B and 2C, interesting. So this is B is interpretability, low and high, versus physiological relevance, low and high. So I guess this is an organoid, sort of the vascularized pattern neural organoid down at the bottom right, which is low interpretability and high physiological relevance. And then you have something like single cell electrophysiology, which is high interpretability, low physiological relevance. And then you have something like a 3D specified neural circuit, high interpretability, mid physiological relevance, and then all these other types in between. So it's kind of like they're kind of putting the organoid kind of down at this end where it's more physiological relevant or physiologically relevant than the 3D neural circuits or the single cell recordings. So, I mean, I guess that's because it's in some sort of context, it's vascularized, it's sort of in a tissue.
Yeah, yeah. I mean, like again, this is very much an idealized figure,
Yeah,
right?
yeah, I know.
In the sense that like surface-wide recordings of vascularized pattern neural organoids,
Yeah.
like is who's doing that? like so I try to attend any talk that covers the vascularization of an organoid.
Right.
I mean, and by that meaning, like like I can't limit myself to just the people working on
Right.
neural tissue, right? And and that's one of the things, right? So the other thing that's idealized about this picture is that all this kind of micro patterning or 3D specified circuits and things like that.
Yeah.
Like you know, uh, all the 3D bioprinting people are working on like muscle, bones, skin, ligaments, right?
Right.
There's so few groups that are actually working on neural tissue. Um, but I do love this paper as well because it's like when I was a student, um, it's like kind of the best I was a simple systems neurobio guy. So it was like get an invertebrate, remove the nervous system and do the kind of single cell electrophysiology, right?
Yeah.
As being that was kind of like what you could hope to do as a student. Um, and yeah, so in these two arms are kind of like the directions that I would love to see us be able to get to. And again, like the MEA, that like how you do the recordings is definitely a part of this technology there.
Right.
But yeah, I love all these graphs. Like
Yeah. Yeah.
I think they're yeah.
Yeah. I mean, this figure 2B kind of reminds me of the argument
Mhm.
people make for embodiment, where like
Yeah, yeah,
embodiment is more relevant to maybe not physiology, but like the real world, and then
yeah,
it's probably higher interpretability, although I don't know how
yeah,
that graph would look like.
yeah.
And then figure 2C, this is technical challenge to assemble, so obviously the larger
Right.
scale things are higher, and then difficult to elicit and control advanced neural function. So it's easier actually to elicit and control function through 3D specified neural circuits than something like a neural monolayer.
And that's that. I mean, again, it's just like I don't know if I should really be looking to Brett Kagan for vindication,
Right.
but like that is consistently been my point about why we should do that. Is that like it is the control aspect that makes it really powerful.
Yeah.
And relating to that is like our ability to simulate it relates to our ability to control it.
Okay, so yeah, this is the paper here. Two roads diverge, pathway towards harnessing intelligence in neural cell cultures. And this is, of course, the comparison between organoid intelligence and bioengineered intelligence. Well, both broadly fall within the wider definition of synthetic biological intelligence. OI and BI diverge in their methods, design goals, and implications. The advantages and disadvantages are analyzed with respect to the existing challenges and future opportunities. OI is a top-down approach that aims to recapitulate physiologically relevant brain structures. These organoid cultures, so they kind of go through and compare the two approaches. And it's kind of one of these vision papers where they're kind of like there's a lot of promises that are made, and they're kind of analyzing the promise of each method. So there are probably a lot of things that are being taken into account. But this one here in Figure 1 too, this what is this? Organoid intelligence and bioengineered intelligence. And then they have kind of this MNIST task. And then they have these percentages. So let's see if the full caption can tell us something about that. So OI and BI may intersect or diverge, but both could be considered as stemming from general attempts to generate intelligent devices for some synthetic biology approaches. In this way, the earlier term SBI acts as a useful catch-all term for the field, while OI and BI would designate distinct approaches. Many experimental setups could be applied to either OI or BI, and there's some conceptual differences. Here, OI involves feeding in encoded signals, which are here, I guess, and allowing nonlinear transformations in activity to result in a collection of signals. A classifier might work on the entire network and result in a confidence score of key options. A similar approach might be adopted for BI. However, different layers of the neural system may be utilized in pre-designed distinct manners, which could result in layers distal from the signaling, providing maximum accuracy. So they didn't really explain the percentages. I find it's just interesting how you're getting these different outputs from some encoded signal that's put into the system, and then you're getting things that come out. So I guess this is the prediction, or the confidence in the prediction, something like that. What is this? Is it a 7 or a 1?
Mm-hmm.
Yeah.
And I just dropped in a couple other papers that are together with the everybody's got an AI company now. The AI company that pays Carl Friston. So versus people have a paper with both Brett Kagan and Adil Razi, who's I forget now. I think maybe Brett is actually the CTO and Adil is the CSO. I forget how Cortical Labs is structured, but it gets at these are additional papers in terms of just how their approach of getting work from these organoids, or getting the classification and I was going to call it machine I was going to call it ML, but it's not ML if it's bio.
it's
BL. Bio.
Yeah. Which is not actually biological learning.
Yeah. So, but it's interesting, again, this comes full circle back to active inference, in terms of how you are approaching the training and the training, control, goal-directed behavior.
All right. So the first paper here is the arXiv paper. This is Adil Razi, Brett Kagan, and then this is simulating biological intelligence active inference with experiment-informed generative model. And so this is where they're actually doing active inference. With recent and rapid advancements in artificial intelligence, understanding the foundation of purposeful behavior in autonomous agents is crucial for developing safe and efficient systems. While artificial neural networks have dominated the path to AI, recent studies are exploring the potential of biologically based systems, such as networks of living biological neuronal networks, which are the organoids. Although there are other, kind of you're thinking about networks in the brain or networks in a smaller connectome, then, we're also talking about that as well. Along with the promises of high power and data efficiency, these systems may also inform more explainable and biologically plausible models. In this work, we propose a framework rooted in active inference, a general theory of behavior, to model decision-making in embodied agents. So this is just kind of just applying active inference to this. We simulate decision-making processes in a simulated gameplay environment. So this is kind of like the dish brain approach, but kind of like extended to this active inference model. Our results demonstrate learning in these agents, providing insights into the role of memory-based learning and predictive planning and intelligent decision-making. This work contributes to the growing field of explainable AI by offering a biologically grounded and scalable approach to understanding purposeful behavior in agents. So this is I want to look at the paper a little bit, if there are any figures or... So what they're doing here is they're basically... first of all, they do mention dish brain. So inspired by the dish brain experiments. And then they lay out the active inference method. So they're building a generative model based on POMDP, which is the partially observed Markov decision process model. And so they're doing that. They're implementing that here. POMDPs offer a universal structure to model discrete state space environments where parameters can be expressed as tractable categorical distributions. A POMDP can be formally defined as a tuple of finite sets, SOUBA. So S are the set of hidden states, O is a set of observations, U is a set of actions, B encodes the one-step transition dynamics, and this is the probability of transitioning to state S at time t given the action of the last time point. And then A is encoding the likelihood mapping for the partially observed setting. So that's basically the model that they use. And they say that in POMDP, the hidden states generate observations through the likelihood mapping in the form of some categorical distribution, which is this conditional probability, and it's equivalent to this categorical distribution here. So this is the sort of the likelihood mapping of a state happening at any time. Okay, so B is a collection of square matrices where B sub U represents transition dynamics. It determines the dynamics of S given agent's actions U as this likelihood mapping. In A and B, the state, they'll take the likelihood mapping and the one-step transition dynamics of the state. This is represented as a one-hot vector that is multiplied through regular matrix multiplication. Okay, then the Markovanity, which is
I don't think I've ever seen that before.
Yeah.
Yes.
The degree of Markovianness, I guess.
Yes.
Of POMDPs. Yeah, it means that state transitions are independent of history. And so this is the state, it only depends on the state action pair. So this is interesting because we actually talked about that. We've been kind of highlighting that in some of the work on last year's active inference talk, where there are these, there's this distinction between Markovian and non-Markovian models. And so it's interesting there. This is So let's see. Yeah, so from the agent's perspective, when encountering a stream of observations in time, as a consequence of performing a series of actions, so the observations are O, the actions are U. The generative model quantitatively couples and quantifies the causal relationship from action to observation through some assumed hidden state of the environment. Okay, these are called hidden states because the agent cannot directly observe the hidden state in the environment, but it has to infer the state um, from, I guess, previous actions. The agent maintains beliefs about S using the observations O. And so this is, it's basically where you're observing the previous behavior, you have a belief about what's supposed to come next. And so um, that's the behavior that's emitted. Okay, so this shows this structure, and this is the game that they play in Dishbrain, where you have this ball, and it's moving around in this XY coordinate space, and it's supposed to predict the next position of that ball. So that's kind of the idea here. And then they go through this. They have this classical formulation of decision making. We talk about surprisal, which is the measure of kind of, I guess, unique behaviors. So, when you have information entropy, you have a lot of things that are, kind of these different behavioral states. And then a lot of that is called surprisal because it's not sort of the same state over and over again. And so recent experimental works, Kagan et al., Strong et al., Isomora et al., use the concept of surprise in the active inference literature to design feedback signals for embodied agents that demonstrate improved learning with time. So this is, again, they're using this concept of surprisal as a feedback signal in the system. So when you get a unique feedback signal or like a distinct feedback signal from a background sequence of the same behavior, then that acts as the feedback signal when it gives information to the agent, and it allows it to learn things like that. It should be noted that an agent is ignorant of the actual likelihood of any observation, and it is not in full control of the environment. So the agent is not directly informed of how probable an incoming observation is. So to estimate P0, the agent must internally encode and use a model to learn and predict the probability of incoming observations. So this internal model is generative in the active inference literature. And so then this is, of course, the basis for minimizing variational free energy of the observations one expects in the future. So then they start to get into policy space and some other connections to reinforcement learning. And then, of course, they have this dynamic programming model to minimize the variational free energy. And then they get into counterfactual learning. And then they get into the results. And they just kind of demonstrate this. So that's this paper, this arXiv paper. And then there's this other, what is this journal here? I've never heard of this, Cyborg and Bionic Systems. So this is, I guess, a newer journal. But it's, the paper here is called Dynamic Network Plasticity in Sample Efficiency in Biological Neural Cultures, a comparative study with deep reinforcement learning. So now they're using deep reinforcement learning and this sort of approach to organoid intelligence to see, the differences are. So in this study, we investigate the complex network dynamics of in vitro neural systems using Dishbrain, which integrates live neural cultures with high-density multi-electrode arrays in real time, closed-loop game environments. By embedding spiking activity into lower dimensional spaces, we distinguish patterns crucial for real-time monitoring and manipulation. Our analysis highlights dynamic changes in connectivity during gameplay, underscoring the highly sample-efficient plasticity of these networks in response to stimuli. So they compare this efficiency with biological systems, a state-of-the-art deep reinforcement learning algorithms. So they look at deep Q networks, advantage actor critic approaches, and proximal policy optimization. And they're doing this in the simplified Pong simulation. So in the last paper, they showed the figure where, this one here, where they demonstrate the Pong game. They have this paddle and the ball is bouncing back and forth, where it's bouncing against this surface and the Pong paddle, and it's trying to predict the next position of this ball. So you can use organoid intelligence, or you can use a reinforcement learning algorithm, and you want to benchmark this to see which one is performing better. Through this, we introduce a meaningful comparison between these neural systems and deep RL. We find that when samples are limited to a real-world time course, even when these very simple biological cultures outperform deep reinforcement learning algorithms across various game performance characteristics, this implies a higher sample efficiency. So that's their takeaway. So yeah, that's these two papers. So this paper, they have their illustration of the dish brain, and they have the setup, and they compare this with deep reinforcement learning algorithms on the same benchmark. And they show some visualizations through TSNE and ISOMAP of the performance here, gameplay, and then the following rest sessions. And so they showed the differences.
Yeah. And just so you see that in the data availability on the right there.
Okay.
This is there's OSF and be really interesting to see how much is there, or is it not there yet?
Let's see. This is.
It's maybe not.
Maybe no. It's private. Maybe.
I will follow up in terms of if you check for those. I was assuming it was there.
Yeah, I don't know what happened, but there's a stub for it definitely. So,
Okay. I will follow up. I mean, again, like one of the reasons that I think there's the so little, if you will, work is going on is that, like, having access to this kind of still somewhat complicated bioreactor is not generally available, and so like next week, be talking with Neurotech at Berkeley. They've got a wetware group of their team, or they've got a team that focuses on this. We're talking about how to expand to be able to do these kinds of cultures, and I've seen data sets from the Wolf group at Munich, where they're doing very similar things about, again, relating to this kind of like what the low dimensional space looks like if you have data sets like these, and what rest versus training dynamics are and things like that. So hopefully we'll get to the point where data set access isn't the issue, and just like how to do again, like how to simulate as well as like design training programs and analyze those training programs. Like it's there's something there, you know. You know, I don't think biological, you know, again, like this is a company who's got kind of an interest to say that biological computing is a thing.
Yeah.
You know, we kind of have been joking about, you know, how quickly will it be before Cortical Labs focuses on drug development?
Yeah.
Because you know, there's an industry to support that, and you know, whether you can be a biological computing company when, you know, when cloud services exist that you can program now, right? And so software and stability and things like that, like are absolutely functional companies that people can get work done, you know, with now. So yeah, but just you know, it's some additional work from Kagan in terms of just that kind of vision paper on the kind of two paths of organoids and bioengineered intelligence.
Yeah, I like that. That's a nice set of papers that they're putting out a lot of stuff on this. They're kind of just going for
I mean, you know, Adil is a student of Friston's, right? And like some of the middle authors are basically engineers at Versus. Like you got a lot of active inference people involved there, and yeah. So I will say that they're not the, you know, this has been it's something that the brain engineers are doing too, you know, and some of that is led by Brett Kagan being publishing with them too, but I think you see this also in terms of just, you know, how active inference relates to control theory and you know, kind of other traditional topics in systems identification and control, right, in engineering in general.
Yeah.
Right. Because like the Hopkins group, you know, the Thomas Harding, Linus Mernova group is doing very similar kinds of things, together with the Applied Physics Lab. They're, you know, algorithmically, there's a lot of overlap, even though they don't use the showy marketing terms, or like you know, the same. Yeah. Um, so
yeah, I like the way they lay out their model in the archive paper. I think that's quite good to like kind of get a handle on what they're trying to do. Yeah.
And you know, like yeah, it's I still see like a bit of a hole in terms of or not like hole, but like it would be nice to just make maybe a more interactive simulation of the Pong as it relates to the as it relates to some of these variables, for people to understand how they're kind of breaking Pong down, and then converting that into the again, like operationally, what does that mean in terms of the stimulation paradigm, or you know, like how are you passing information to this biological construct?
So you have to take the feedback they talk about,
Yep.
surprising being like
Yeah.
some surprising event or different type of event, you stimulate the brain tissue, and then it somehow
Yeah.
it helps it to learn that that's maybe an aversive
Yeah.
stimulus or it should respond. But
Yeah.
like,
Yeah.
I mean, like thinking back to some of the experiments in like Hebbian plasticity, like what does that look like? What kind of signal do you actually have to send, and how efficacious is that signal? Is
Yeah.
it automatically, supposed to work, or is it just kind of like a generalized response of the network, or
Yeah.
what is going on?
Yeah. Yeah. And then it's, like how are you, and then how, in the analysis of that post stimulation, what kind of changes are you expecting, and how does that in the to use Firstonian language,
Yeah.
um, how does that relate to your manifolds?
Right.
um,
Well, I'm just thinking about like if you had a change, or if you had a, you stimulated something in response to a stimulus, in the brain tissue, and you got a response. Is that response always a positive? Like it's think of it in terms of reinforcement learning. Is that positive reinforcement, or is it just a signal that gives a response, and that
yeah,
response might be the same if you have the signal or not? Like it's
yeah,
basically like almost like a semi-stochastic response that
yeah,
is maybe a false positive. So
yeah, yeah,
they you can play the game Pong effectively, but it's a pretty low dimensional game.
yeah,
Maybe in a higher dimensional setting, you'd start to see these false positives crop up where it's actually making mistakes.
yeah,
Yeah.
yeah, yeah. No, anyway, I was um, I was suckered in by the data availability,
Oh yeah.
um, and was hoping that yeah. Anyway, I really do like I want to do a lit search that is like very with a wide net, but that focuses actually on just one particular output
Yeah.
in all of these papers, which is how many of these papers actually have code, how many of these papers actually have data sets, in terms of things that students can play with right now. Um, um, and yeah, and then I've got to start a a name and shame campaign or something. Like, come on, people, let's get some data sets out here. So yeah,
Yeah.
it
Yeah.
would be, but I would like to see that. I would like to play, like again, like this should be an easy simulation, and how best to understand these learning paradigms when the signal is so binary.
Right. Right.
Uh, yeah, like yeah. Um, anyway,
Yeah. Okay. That's great. Thank you. So yeah, that's great. Thank you for all the update on that, and then getting into the papers. Those were pretty good papers. Um. So yeah, hello Jesse. I see you've made it. Of course, yeah, it's fine. Last week Jesse was at the MIT event, and we did a stream where he was going around on his phone and doing kind of a live tour of the event, and I thought it was pretty good. We have it on the YouTube channel, and I don't know, Jesse, if you wanted to report on any follow up from that.
Yes, I do. Give me like one more moment to try to set things up here.
All right. Well, yeah, it's good because I have a couple more things to report on here. So the first thing is congratulations to Vidhi for posting this post on Sustain Hub, kind of like the summary of Sustain Hub. And this is it kind of goes over the vision what's involved. So there was a lot of reinforcement learning. There was a lot of modeling using multi-arm bandits, agent-based modeling, and development of a number of metrics. So during our open source meetings this summer, Vidhi was able to go over a number of metrics she developed to evaluate performance, and they look like pretty good metrics. And so, yeah, then she lists the pull requests that were made here, and yeah, that's largely for the benefit of maybe future students or people who, um, are interested in how you contribute things in open source. So yeah, there are a number. So we had the SARSA implementation, multi-arm bandit implementation, different metrics, the harmony index, the resilience quotient, the reassignment overhead, and then of course the graphical user interface, and then the final README. And then we had, of course, the core methods, then this application reinforcement learning, this dual level of reinforcement learning. So there's agent level reinforcement learning and community level reinforcement learning. And then, of course, our key metrics. And then this is the Sustain Hub model, sort of models the fairness and efficiency of task distribution in projects, so we can understand sustainability in open source projects from the way in which tasks are distributed. And this should allow for consistent, meaningful contributor participation. So then this is going through the weekly timeline recap. So I believe that, yeah, she posted a midterm evaluation post, which was just kind of like a midterm check-in, and then this was more conversational. And so, yeah, if you want to understand her project, go to these two posts here. Yeah, so congratulations to Vidhi for completing GSOC, and hopefully everything is, that you continue on in your work. And I don't know if you want to continue with this project, but now it's an open source project on our GitHub, and maybe next year's GSOC we build upon this. I'd like to actually return to some of the active inference stuff too, because this was something that Brian McCorkle did several years ago, where he did some active inference work on open source sustainability, and kind of bring that up to date more. He applied POMDP, some models of collective behavior, but then it's like, we didn't have no one else took up that mantle, whereas we've been developing reinforcement learning stuff for several years in a row. So it'd be interesting to kind of get that, and then kind of get the active inference stuff aligned with the reinforcement learning stuff. So that's congratulations to Vidhi for her completion of the program. I don't know if Jesse's ready now.
I can get started. It'll be a bit of a slow start. I'm having some issues with my other with my devices, basically. But I think you can hear me okay for the moment. I would have loved to have finished my draft so far of what it is that I am put together. Probably the easiest thing I can do is slightly go over the email that I sent out, actually. I realize that now. Maybe I'll just do that. Because I sent out a data and direction email, and that's a pretty, fair capture of things. So, I mean, yes, it was, there was some mentioning of Frontier Tower, but Morgan wasn't there. We missed Morgan. I don't know if, I don't know if there's anything we talked about earlier, but here we go. Yeah. Yeah, I'll go through stuff. So I think this is sharing now. Does that look normal-ish?
Yes.
Okay. So this is a particular email that I sent out to data and directing folks, but I'm just going to focus on the first part, really, which is all this stuff. Um, I don't know if I can do LinkedIn on this very well, but essentially, here's some nice pictures. When I'm breaking it, it's so funny because I've written so much stuff since I made this email, and it's like, oh yeah, and it's like I'm like, and this is where I go into this part. But essentially, um, to recap the event as a whole, it was really good and really impressive in a way that I didn't expect. Um, you can see my super brief discussion here. For those who don't know anything about the Aug Lab, I didn't know about it. I didn't even get what it really was. But really, what the Aug Lab is essentially um, it is essentially a 2 to 3 month summer program. And you kind of live in a hacker house and you make stuff. And what the Aug Lab Summit is this. It was like their finale. Like they show off, they do their demo day. That's what it really is. And I didn't quite understand all of that when I first um, figured things out. I've done a few things with them or not, but I didn't fully go into the event knowing that that was the setup. And it made quite a bit of sense. If you can, yeah, here's the agenda, just to go through that quickly. Opening stuff. Ecolapto, who I've done a bit with recently. Augmentation Lab, I've been doing some things with them and gone to a few of their events. Pulse, I'm least familiar with, but these are sort of the main folks about it. The first session was essentially someone from the Media Lab itself going through what the Media Lab is and how you can apply, which is cool. And then some iconic professor, Hiroshi Ishii. A lot of cool stuff. He kind of just laid a big time overview, mentioned his heroes and gurus. I don't have any great pictures of that I can easily show you, but there were some photos from it. And it was interesting to see his take on things across time. Like there was like old school information theory, cybernetics people, um, not like Norbert Wiener per se, but like people from this era of going 40s, 50s, 60s up through. So it was a nice historical take. I think it was really cool, and it's not like the most. It's not. I'm sure a lot of folks would do it if they could, but the fact that both Ishii and um, Wolfram were there. Wolfram was sort of the finale person, but there was a really nice element of older generations contextualizing things, and I don't know how intentional that was or not. I'm sure it was somewhat intentional, but for a lot of it's not. It's one thing when you have nice big names and people you can easily draw on that want to do this stuff, and that's sort of one of the major perks of being housed in Boston, you know. But I in an ultimate Jesse version of the conference, I would have even teased it a bit more, or like tried to have a session for like Wolfram and Ishii and maybe a few other like really senior folks explicitly mention context and the development and how the moment that we're in is different than the moments that they've been in before. Because I think people I continue this is a side Jesse sidebar comment. I continue to realize how much um one of the things I'm writing about in the summary piece, which is not just a summary piece, but a collection of many of my thoughts, is literally narrativity, is literally the pressures of the current moment on narrativity. There's a commentary on um, alienation and the lack of coherent stuff. Very much present shock, very much future shock into present shock, into all this stuff. And I think cross-generational perspectives, at the very least, give this sort of core message that you too, like things matter, and you will be at a different developmental stage, and you will be able to speak to the folks that are now in your shoes. And like sometimes it doesn't seem that obvious until someone says it directly to you that you are part of the continuity in spite of a lot of pressures in the world, a lot of pressures in the world right now against it. So I think on that level, it's very fascinating to see a lot of what was taking place here. But back to literally the regular schedule of the program. The next section, which I didn't really get to see because I kind of got this call like, hey, go out and set up exhibitor stuff. So I didn't really see much of these. I did see the first one though with Doga, but these are basically the longevity suite of stuff. Basically why you should do it, care about longevity. Here's, you know, a method that's going to be promising, and then Ellen's sort of a celebrity influencer person who was like, how do we popularize this? And then kind of simultaneously ish was this exhibit space. There was the there was the hall of exhibitors, which is where my live excellent in quotes live stream video took place. It was not the highest quality, but it was a nice behind the scenes look. And then at the same time, which is a little tough, but I mean it makes sense. With interesting startups. I knew some of them. Sylvan AI is the one with Dan Van Zyte that I mentioned, sort of being state of the art AI related, and some of the cool stuff there too. These are external folks.
A lot of those are at Frontier Tower.
I'm sorry?
A lot of these are at Frontier Tower.
Oh, really?
Yeah.
Oh.
So you know, Muse Bio works on our floor. I mean, you know, because it's biotech. Eternus is on the 11th floor, and R3 is not directly working with us, but actually I've got to credit R3 for donating so much stuff to Biopunk. So thank you, R3.
That's cool.
And yeah, and I might know some more of these too, but this also reflects the fact that Pedro and Vic, who were organizing this, yeah, obviously highlighted some people from the tower.
Yeah, and there was a mention of front, like maybe they talked about it more here because I was like at this time I was completely not in the room for like this stuff. So maybe the intro mentioned them specifically. I wouldn't know. But there was a mention of Frontier Tower during the intro. Dunya was talking here, Adi was talking here, and the other gentleman was here. And there was a little mention of Frontier Tower somewhere there. Yeah. So that was this lunch, this time, and somewhere around here is when actually the video that I took was made. Lunch, then keynotes, human machine symbiosis, and these two folks from the Media Lab. You may recall Natalia is I don't think I listed here. Yeah, she's behind the Your Brain on GPT paper that's going around everywhere. And it's very interesting because she basically changed her presentation like the day before it happened. And she did a lot of, I don't have any good pictures to show, unfortunately, but her presentation was essentially about bodyful, bodiless, and sort of she basically, most of her presentation was essentially an axis on screen, a 4-quadrant axis. And it was like, here's like really embodied, here's not embodied, here's like really invested in artificial intelligence, here's like less invested. And all these different versions of these dichotomies represented by popular films and like contemporary sci-fi. She does a lot with, but basically she does a lot of this sort of I've been to some of her events, like at a local like museum, a local expo, where she's like, let's look at like these sci-fi technologies and everything else. And so there's this like very try to map certain thought spaces and things like that. And she basically made her presentation a tour of all those different spaces with some axes. So I wonder if that's something that she's working on specifically, not repurposing the video per se. She's already done that in some of her work, but like I'm curious if it's what she'll do next. And then Pat is I put anything here for him? Pat, for those who don't know, he's now a professor at the Media Lab. He's got his own working group now, and it's the I think it's called Cyborg Psychology proper. But he was with Patty Mays at Fluid Interfaces. He co-directs the Advancing Humans with AI, AHA. It's the AHA program, which I'm a fan of. Yeah, I really enjoyed his talk. And I'm going to feature it a lot in my write-up. I don't even put all the slides here, but that's his logo. There was a very good his there was it was a really 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 rich talk. And I think in terms of conveying it to everything else that I want to do and am doing, it was my favorite talk. Because, and I don't have the pictures in this particular, Twitter post. He went into things like new technology, old pedagogy, and he has that sort of classic image of the students sitting in a class, like kind of like almost like comic, or I want to say woodshop, wood carving, but like the very old school illustration of students in a classroom at a desk strapped to like some machine that is like electrically connected to a teacher professor, like grinding books down, and that image. But then it overlays it with like, this is AI and this is an LLM and this is what and it's sort of like getting really at some of the systemic stuff. Like a lot of this, I wouldn't say the focus is on changing systems per se, but very much this augmentation, meaningful augmentation as flourishing, and flourishing as being what he's trying to center in his working group. So technology supports human flourishing, and then he went into these different components during his talk about wisdom, wonder, and well-being. He mentioned future view. He mentioned a number of projects that have happened. And I'm very excited, honestly. I've been trying to think about what to do, because I do want to do more education, and I might even just apply to his program, because I like it. Although a little bit later, I might talk a bit about some of my future directions in that. So yeah, where are we? This is great. I really think just being able to pull these two keynotes from the Media Lab. Granted, like these are like Dunya's in the Fluid Interfaces group, and so and many other people in the Augmentation Lab have ties here. Yeah. But to go from this panel, from these keynote section to this panel, was huge. My real favorite parts of the whole series were the panels, just because of this was the talks were cool, but they were kind of you didn't get to dialogue about it. They were just sort of like it's like condensed lectures, or here's some key points that I want to share. The panels were fantastic and changed what the event was to me. So there's this panel, and then I'll get to one later that was R&D for the future, with Prospera, Harry Gandhi, and Sam Rowe from Athos, which is a local, I don't know, startup incubator type group. And then Addy from Ecolopto. Originally it was supposed to be Dunya, but Dunya wasn't available for this basically. So Addy kind of stepped in and was sort of a co-moderator and shared his own experiences. And then also moderated for Wolfram later. So good job, Addy. Addy stepped in. Addy's 23 years old, and he's taking a lot on to do this stuff. And he really makes things work, and puts a lot on himself to do it, and I hope to support him ahead in a lot of things. But shout out to Addy for making a lot of stuff happen, including being in support of this event. But yeah, the panel, I could spend a lot of time here in both of these panels, and I'm going to spend a lot of time in my write-up dissecting points made in these two panels. But to stay chronologically aligned at the moment, I don't have any good pictures of this. Here, this is the panel proper. And I think it might be, it's, yeah, I don't know, it's the same image. But no, like this was extremely relevant and interesting because because I like this slightly better right now. Because I guess the title, I don't know if it says any more about it. Yeah, the future work and meaning from an author who's also a lawyer. Kendall's a really interesting guy. Juliet Schor, who really got the econ perspective, and Greg Epstein, who's this chaplain at Harvard and MIT. Like he's a religious, I guess, a scholar, but also a chaplain. And it was really interesting. And I didn't know, like my excitement level for the event, if I knew, I mean, I did know I was going to be there, but like, I didn't know they were going to be kind of encouraged to talk about what they did, and both panels even. But even for this one in particular, it was just a very nice mix of, this is why I mentioned earlier, I mentioned narrativity, I mentioned present shock, I mentioned meaning, I mentioned alienation. And so for a bunch of tech folks talking, like these things were on the table. And I regret, like I kind of wanted to get, I didn't have time, or I was in the wrong mindset to think I should just go get a book signed by Ken Liu and talk to him directly afterwards and like do that more. Like I should have done that. I didn't do that. I regret that. But just for there to be essentially a bunch of nerdy tech folks where you have this panel with both the meaning making of it, how does it affect work, what do we do, like the contextualizing that was done here in this panel, and even for the R&D panel, is exactly what future technologists, in my view, need to be thinking about. Because the other side of the coin that wasn't said here, although it was kind of hinted at from a number of folks, like even Natalia kind of commented on this, but there was no explicit commentary that's like, hey, like a Karen Howe commentary, Age of Empires commentary. Nobody really said that outright. Not that they were avoiding it, but like the only thing missing from the contextualization process of this conference to me was Karen Howe, Age of Empires, Empires of AI. Although it is Age of Empires, like that's how I'm actually referring to it myself. That's why I'm saying it. Like we are in an Age of Empires right now. So if you take that aspect, Karen Howe type work, and then this meaning making, and you contextualize it and say like, Pat, okay, like meaningful augmentation, like like how do we do that? What is that? What is flourishing like in that sense? Is like hell yeah, like that's like the challenge. Like that is it. And maybe We Robot. If you throw in like a good dash of We Robot, you would have a really wonderfully complete, like as in like the policy side, the horrific policy landscape that lawyers and good natured and well-meaning people are hopelessly attempting to stem the tide, to be a little grim about it. But and I'm kind of meant saying this because I'm saying this out loud as I'm thinking like, if I could design a conference next year, what would I want it to look like? So it's like a little Princeton Envision, a little We Robot, a little Karen Howe, a lot of Augmentation Lab summit, a lot of this panel, a lot of that panel, a lot of these keynotes. Like that's like what should folks know, and then framing it that completely. What can you do with it? That's where my mind is, yes, going for some things. Needless to say, I very much enjoyed the panels, including this one. There are a lot of great quotes. Greg did a wonderful job of like really calling out like, hey, I know you're all talking about, technology, but is this not like messianic and apocalyptic? Like, are you not putting your faith in certain outcomes that let's just get to this end state and then we're gonna be all great or gonna be all bad? Like he did a great job of drawing out the religious parallels that I think are unpleasant to look at for people that maybe think they're very rational and have absolutely no bearing to the faults and sins and wrongdoings of the past because they're building a technology. It's like, well, okay, so that was cool. Ken had a lot of really good perspective and contextualization on the human condition, and Juliet brought in some, one of her takeaways was the defense of the four-day work week or 3-day work week and main pilot program that she's doing with that, but also just at its core, sort of the defense of having time to do stuff like you could say sovereignty, autonomy, the defense of you as a human being, you can have time to do what you want to do, as opposed to present shock, as opposed to everything. Well, just work more, work more, work more, work more. She kind of gave a little historical perspective of when industrialization happened, like and all these things happen where it's like, okay, well, there's a new technology, but okay, everybody's work more, work more. We can now everybody work more. But then these movements coming in to say, well, maybe we should have, child labor laws. maybe we should have things called weekends. Like there's sort of the productivity goes up, but then maybe isn't accounted for, and the adaptation. And I think that's a fascinating nexus because the rapidity of the changes now versus society catching up to them, that is where we're in. That's the exciting, challenging, crazy time. That's the moment. That's the timeline we're in, and that's something that I'm trying to emphasize for many folks when I talk more and more about this. So yeah, super quick preview. Elise was the moderator. She's doing some things with Sloan. She's a good moderator. She brought out a lot of the different segments well. So kudos to her. Let's see, where are we at here? I'm not going to go through all the residencies because there's a lot of them, and you can look at them on the Augmentation Lab website. But this is when I was like, oh, like this is what the residency, what they've been doing for the last while. I attended, this is Ron and G or Parth, and I attended an Echolopto workshop salon with him a few weeks ago at Harvard. He's interesting ideas about the future. So I'll just shout out that. There's many interesting things here. And also some past residency projects that were really interesting, like narrative tales or conceptual tales that fit a lot with plot twists of what's going on there. So yeah, we had more exhibitions, book signing. The hypnosis session also was super fascinating. I could say a whole lot about that. I don't think I have any easy pictures from this here. This was actually way cooler and more interesting than I thought, especially when actually combined, which is kind of funny because you can see like the time's a little weird. When actually combined with Andres from QRI, if you got these folks together and like spoiler, that's basically what happened the next day. It's not on here, but there was this is what happened the next day. Kurt was originally supposed to be at the Media Lab event proper, or the summit, and he wasn't. So basically, he did a little recording with Andres the next day. And where we're going with this, and this is me being a big time nerd, where we're going with this is if you combined the QRI stuff with the hypnosis stuff, it was so interesting. And also, I mentioned somewhere in here, the QRI stuff and the hypnosis stuff really had an interesting job of kind of triangulating or like pinging, like sonar detection inside, pinging around inside the black box to see what's going on. And with the hypnosis was, it was cool to see people, whatever, but there was sort of like, oh, now how would, let's say your Grok or ChatGPT, how would you respond to this? And like, okay, that's funny, but what it did, there's a great, I'm not going to try to find it, but Andres on Twitter later said, oh, like you can clear like jailbreaking some of the LLM structure of mind stuff. And of course, I think of Elon Barinholtz, who's doing a lot of work on that particular topic regarding languages, LLMs, and stuff like that. But basically, these people get into a suggestive state, and then you can using certain stimulus, and I thought it was very clever and very interesting how Albert, he asked one of the attendees, like, "Oh, are your friends here?" And they're like, "Yeah, we know him." And he's like, "Oh, does he drink much?" And what he was trying to do was like, does their internal storage know what it's like to have a beer or two beers? And he demonstrated, one, seeking the awareness of it, but then also like he basically produced doubling effects of, okay, you've had 1, 2, what about 4, what about 6? And like he was able to connect the internal structure of the person, getting confirmation that, because he didn't want, he was checking to see, he didn't say this, but I deduced he didn't want to give the person commands that they had no exposure to. It's like, well, pretend like you're high on a drug that you've never had before. Like he wanted to avoid that. And I was like, okay, yes, like that makes a lot of sense. So the way that he crafted it was interesting. And the way that between that and what a lot of the QRI talk was about was essentially, yes, drugs, but more like, what are these select stimuli doing, and how do they, the QRI and Andres is very phenomenologically interested. So a lot of like, I got to ask a little bit about like, okay, like here's the Varelian lineage of trying to bring rigor to this. And I have a lot of respect for like, there's a little bit of overlap between like the interviewing, where was he going with unbecoming aware, where was he going with like the second person stuff? How do we get from first person to second person to third person, the ways to evaluate this and make it more rigorous? And it's like, here's like what the QRI is sort of doing to that sense. So having that combined with Albert, who again, Albert was not presenting himself as a scientist, but he mentioned like threat simulation. He mentioned the going, I forgot, not catatonic, but like when you rub the shark's nose and it just limps out and like stops moving, like all of these different actual like somewhat rigorous studies of like, okay, well, nobody knows. He's like, nobody really knows what this particular state is or how to talk about this, but like here's what we can do in this state. So it was quite a compelling, and not at all a sideshow, but actually quite compelling in the sense of, especially for this crowd, I think it was a really nice, interesting choice. And I know that Addie's done a little bit with Albert before, in like Toronto area or whatever, but it was a very interesting component in a, here's an existing very clear augmentation within current bounds, within no new technologies. This is just like this kind of like, this is what you're working with. Like this is part of the inherent system that can manipulate it in these ways. So it was an interesting combination between these two. I'm not even going to talk about Wolfram because he's a cool guy. We all know him really well. He's a great. And no, I will say a little bit, and I don't know how much time I have, rather like a minute or two.
Oh no, you have as much time as you want.
Okay. Do I have a good picture for this? I don't think I have a great picture easily here that I can share. Suffice to say, this panel was also fantastic, and I'm going to detail quite a bit more of it ahead. Let me really quickly look to see if I have. Oh, the link, LinkedIn. How convenient of me! I forgot. Like, I made this post. Yeah, great. Cool. Pat myself on the back. So here's what the panel looked like. And again, this is going to be Dunya of the Aug Lab here and Dunya of Fluid Interface and stuff here, but she was unavailable for this. So I'm just going to read my post and then say more about it. There were so many great things about the Aug Lab Summit this week. Particular shout out to the folks on the panel. It was refreshing to see the way everyone spoke about doing research and developing ideas, as many R&D spaces and approaches aren't that interested in actually changing or challenging systems at large. This week, I've had great conversations with our Jopra interns about the different areas innovators will find themselves in and how to speak, understand, and navigate them as we push ideas and projects forward. Both panels, as I already said, I like both of them. This one and the future work, meaning the first one, really hit home on the goal of centering the human condition, building from within the that should be the actual world we're in right now. It's quite welcomed at a time, as I kind of said before, where it's often more convenient to be abstracted and disconnected from our current moment, the current moment we inhabit, as fragmented, narratively disputed, present shocked, digiphrenia laden as it may be. More on this later, which is what I'm going to talk about another write-up. So kudos to the organizers, and cheers to folks that are doing all this stuff. So that's my, glowing take on things. But what was really cool about it, I didn't know a whole lot about some of these folks and what they're doing, but Trey Joff is it's not really here, is with Prospera, and I'm not even going to try to explain what's going on, but Prospera is essentially trying to rework some things about economics and laws and innovation, and there's a special economic region in Honduras. And I don't know if Morgan or anybody else wants to say and step in and comment on that, you can. But it was really interesting to see what he and Prospera are attempting to do as like actually changing, well, not changing, but like experimenting. I see it as an experiment, and how do you get people and countries and how do you try to create these different environments? And this is like a very hands-on approach, not just sort of let's make a lab. Like, no, this is like let's make an economic arena where you can do things in a certain way. Then I'm sure they're not without controversy. I'm not saying this is the true way forward, but it's very interesting to get a take from that level. And it was also supremely interesting to see how everybody spoke. Trey is very much, DC speak, and American politicians right now, I think, basically have to speak. There's a very particular cadence about solutions, and here's the problem, and then here's a solution that will bring you success. There's a very particular way of speaking that he embodied, which I found very interesting, and it was totally disharmonious in some ways. No, well, that's not true. That's there wasn't any disharmony, but to, I guess, would say a trained eye or a trained ear, and someone who is spending a lot of time in writing materials and educating others about talking different arenas, it comes across in like he's got his whole look. He looks like a DC lobbyist type. Someone who's going to get down in there and make some deals and advocate. And it was interesting to hear that compared to like Addie, who's probably very far away from that. And then you have this Sam from Athos, who is Sam and Harry were both sort of these community-oriented, softer-spoken, more aware, more presenting a certain space for things, and what they were doing. And I say this not presenting Trey as some hard, cold person, not at all. Like everybody was on the same page at sort of the spiritual level of what was happening. But it was just so interesting to see to get the differences in the room. It's very society, ethics, tech spirit of get the different people who are like in very different domains that care about the same stuff in the same room. So I might have presented this a bit awkwardly, but like I think it was fantastic to see that. Like it's great to see get people who don't talk all the same way. Because if you're in a room full of like educators, you're a room full of idealistic tech startup folks. If you're in a room full of billionaires or wannabe billionaires, like the tone, the conversations are all that can kind of wash away into nothingness and like, oh yeah, like this is how this we all talk this way and we all see the problems the same way. I find it to be sometimes it's great to do that, but I really appreciate when in an effective way, when in an interesting or let's uh, uh, meaningfully ways of indicating the differences that each of the domain spaces are trying to solve. Uh, when that can be shown usefully and with substance to a viewer who is not to a lay viewer, I think that's a huge that's a very rare thing to do well, and I think it came across really well here. Um, Harry Gandhi's Teal Fellow, which I was like, okay, what's that about? I mean, I know what it is, but like I didn't know what his approach was going to be. And I wish I got to spend more time with him Sunday because there was a lot of folks had this great opportunity to have lunch with Harry, and I kept trying to go to it. My travel plans got delayed, but I really want to catch up with Harry because the way he spoke about things, he was super aware of like community. Um, he had a really nice set of commentaries on like what does it take at a how do you do the future of R&D? How do you make communities different? And it was very much not get to market and get your moat, like your technological moat, your strategic advantages. Like that's obviously that's I think understood for everybody here. But there was this very interesting emphasis of what you need money, you need clout, you need respectability, you need legitimacy, but you need community. You need. There was a very open inquiry to like, what is it that we need to do um, to create the environments that maybe will lead to actual breakthroughs. And there was sort of across the whole panel, there's sort of this open sense of not being beholden to any particular structures, which I found very structures or establishments, but also um, it wasn't willingly blue skies thinking either. It was really nicely grounded in let's do things intentionally with some difference that aren't just willy nilly. Oh, let's magically do whatever, and aren't just the only innovation that matters is the innovation of you delivering profit at a lower cost to the delivering more profit to yourself by lowering the cost of delivering value to the consumers. Like that is innovation, and that's sort of my intense juxtaposition of like there's parts of the world where like that is the innovation that matters. It's like lower the cost and get more money and deliver the value. And it's like, yes, but there's also other things to do in an innovation sense in how we do it. I think it was well modeled here. Addy did a very nice job of stepping in quite last minute. Um, he represented Ecolopto well. Ecolopto is in development on many of what it's aiming to do and who it's supporting and how things are happening. So I think it was a nice perspective of, your you can be a young person, you can be striving to do these interdisciplinary spaces. And shout out to my forthcoming talk on I don't know if I can easily share this here or not. I'm going to do this. I don't think you can. Can you see what I'm sharing? What do you see on your screen right now, out of curiosity?
The LinkedIn tab.
Okay. I'm going to tease this because this is incomplete, and I don't like the title at all. But basically, so what do you mean by interdisciplinary research? And what it's really going to be is like interdisciplinary, undisciplinary, transdisciplinary. Like, what is this? And then, sort of in a Joe sense, where do I think all this stuff should go? Yes, contextualize in that we're in a very unique moment in civilizational history in that context. But to go back to this proper, Eddie's part of why I'm a fan of what et.al is doing is like there's sort of a no holds barred, let's put stuff on the table. There's definitely a sort of a bias and interest in certain like cognitive, biological, hormesis stuff, and that's Addie's personal bias. But they do try to get other things going on too. And then, like I said, Samro was a proper moderator, but he did a good job of sort of feeding around. He did a very good job of setting things up. Like I've kind of impressed by Ethos, and I've talked to them before, and I've been in one of their events, and they've been really inviting. Like I could see myself wanting to do something like what Ethos is doing long term, or joining them or something like that. So shout out to Samro for, I don't know, I was very impressed at how much this didn't fit some of the things that I thought would be here. And given this is sort of I don't want to say progressive because it's not really it was legitimately actually R&D for the future and what do we need to do. Like it didn't really feel like many other things felt. I don't think it was like supremely unique or like irreplaceable. But between this, as I said, between this and the first panel, there's definitely an appreciation for like I say somewhere, I think in my full write up, I say the only reason, like, because you could easily do this event right without either panel. Like you could take away both panels and say, hey, here's our residency summit. We have a couple keynotes from the Media Lab. That's great. Also, there's a wonderful yeah, this slide, I'll highlight this slide. Yeah, a cause near and dear to my heart. This is actually at the start with Dunya doing the intro here. But there was a legitimate actual inquiry, like how do we want to do this? Philosophical yearnings. Like it was evident that the construction, particularly of the panels, I would say, was we want to have these voices in here that are going to actually bring ethics and vision and society into the discussion in a way that's not just sort of hand waving or not some, oh yeah, and here's our keynote speaker at the very end of the day that's going to talk about responsible AI, which many events in Boston here do. So it's nice to see things handled much differently and much more like we value this, and we're going to make space for this, and we're going to have this be a real part of the event and not just a little add-on. So that was quite cool. That was pretty much the whole deal. I think I already mentioned this was a really fun moment. It was on the fly. It was one of my probably my biggest claim to influencer and somewhat whatever renegade academic fame is that I hand delivered a coffee, black coffee, no sweetener, to Andres, and I got Kurt a bottle of water from an vending machine when we couldn't find any water anywhere. So I And he's like, "Oh, now you sponsored the event. That's great." So I was like, "Yes, I helped sponsor the summit and this amazing Theory of Everything with Khajehnejad podcast." And yeah, so that was fun. It was a fun day, and we all had lunch afterwards. We went to a local place and sat down. We're big time nerds for another hour or so. It was a good time. It was a very fun weekend. Um, I'll stop sharing my screen, and thank you for the whirlwind tour of it. And any questions or comments I can try to get at. I talked for a long time. Wow, I'm sorry.
Yeah. Well, I think I have the Philosopher-Builder thing down. I was going to ask about that, but it seems like they want to inject philosophy into building or engineering or something.
Go ahead. Yeah, I'll say.
So, but then I was just kind of curious what Stephen Wolfram talked about in the Q&A. Like not everything, but just like one or two takeaways.
I didn't stay the whole time for it for myself, but like I'll give you the first few things that he spoke about. One of them was he gave an intro to himself. and he like went through all the things that he did, and he said immediately then like, man, this is a terrible introduction because it was so long-winded and also like, yeah, I did this for a while and then I decided to do this, and he tried to give like a very brief overview of his stuff. He also told this story of I think in like 1984 when he like something from the 80s when he was also working here like in Boston across the street, and saying, "Yeah, I was here for an event," and I forget what thing he just released, but a reporter he stayed at a hotel, and a reporter called him and said like, "Hey," called him like 4 in the morning, like, "Hey, can you give me a one-word summary for this thing? For like who you are, like, or give me a one-word summary for who you are and like what you're doing, or the one sentence summary." And it's at 4 in the morning, and he just goes like, "No," and hangs up the phone. And then he's like, I from that point forward, I never like he always tried to make sure people wouldn't just go to like call his room and stuff like that. So again, it was sort of this nice like it was cool because like it's just so casual for him to drop like this from the 80s, this from the 90s, this from the long term perspective that I said at the start of my little review of things. And then he there was this big long waving discussion about like the brain and the mind. I'm trying to remember a specific detail about it in the sense of there was a point he was getting to, but he went through this just like this history of like how we've thought about the brain. Obviously, he mentioned a little bit of like why did he do a new kind of science? What was he going with all that kind of stuff? And he went into just like how the mind and the brain in his mind kind of came to be where we are today with them, and what to do with them ahead, and the structures of them, and kind of typical neuro stuff. But then there were a bunch of questions like, oh, what is augmentation? Where do we start with augmentation? How do we do this stuff? And I don't have a lot of great, cool things to say about it because I did leave. I stepped away for a good while at that point to handle some of the things. But I'm sure it was great, and I think I do want to go back. I think everything's gonna be recorded, and I'm quite curious to see what happened with it. I'm sure Addie did a great job of facilitating what was certainly a bunch of a full house still waiting to talk to Wolfram. Oh yeah, Philosopher-Builder stuff. I mean, to be honest with you, like I kind of wish there was a little bit more about saying what that meant to them, because I didn't. I've as an outsider, like my only really exposure to the Augmentation Lab was I did some things that I was at an Ecoloptus salon at their house, their hacker house in Cambridge, Harvard Street Commons, I think is like the formal title for whatever it was, and a few other like adjacent things there. But I didn't. It's quite clear that there's a legitimate focus on essentially Philosopher-Builder type things, But as an outsider, I wasn't like, I'm really curious. I don't know they have like a developed philosophy of it, or like as in here's our principles that we're advancing. I do know that their Discord has a like a tech ethics channel. I do know that it's clear that they care about it, but also like I think I even actually I asked Dunya at one point in Discord, like, oh, like, are you guys doing anything specifically here? And I didn't quite realize like that they're what Og Lab does, or I should say maybe has done, is just like these like summertime 3-month hustle periods, and they haven't like built out a framework, which is maybe something that more actually what JoPro is doing, and that's kind of why I might look into doing more with them next year. However, as this little bit of a I don't know preview, and maybe even Morgan knows about this. I think a lot of the folks are basically going to San Francisco, and so the future of Og Lab in Cambridge is a bit open from my current understanding of it. I'm sure there's a lot of critical mass here, as in Boston, Cambridge, but to be determined. So where to go back to the philosopher part, um, I don't think that there's a crystallized sense of what it means for them to do it, but it's interesting because Philosopher-Builder is also the term like Cosmos Institute, which I somewhat I talk about now and then. Like that's their term. Like we are the academy for philosopher builders, and it's like, well, you seem to be like that, but you seem mostly be talking about a lot of um, classical Western philosophy and making tools around it, like for mostly democratic-ish purposes, which I think is great. But like, I think a lot of what I want to do, like I want to make an essay contest. I want to make some other things that are, uh, I want to encourage Cosmos Institute to stay in that lane. And I have a lot of like, I don't think we don't have like, we're not like buddy high five and bros on Twitter, but like things that Brennan McCord posts are things that I legitimately think people should be thinking about. And I want Cosmos Institute to do what they're doing. And then essentially with Joe and some other stuff, I want Cosmos to stay in its own lane and do what it is doing at Oxford, because I think we need a group that is taking the Oxford old school Western philosophy folks and giving them an on-ramp to, hey, give a damn about feature and AI and bring your ethics and do this. I think there's a need for that. But I think that's one lane in a multi-lane highway of philosophy and being a philosopher builder. And I think a lot of what Augmentation Lab did as their take on philosopher builders is quite important. And I want to add something to the mix through JoPro specifically as well. And a lot of what we've talked about in like society ethics tech stuff, but also like legitimately centering some other voices, approaches, and so on. So yeah, like it's not like come be a philosopher builder was really the rallying cry. Maybe it was, but I didn't really know that was going to be a main theme of the event. And maybe I'm just ignorant or like foolish and misinformed about it. But I do think it really came across well. Like it could have, like you could have phrased this, you could have had this exact same conference, which is quite cool, I think. If you presented this conference as Philosophy Builder Conference Summit or Philosophy Builder Summit, it really could have held. The only difference would be the projects and some of the exhibitors and some of the things might be like slightly less, I don't know, conventional Boston kind of biotech, biohacker. Like it was a little bit of like augmentation. It was legit like the exhibitors and talked were augmentation focused specifically and not philosophy builder focused. But like if you just swap that out, like you could basically make this a much more overtly philosophy builder focus, which is quite cool, I think. So good job to them for that.
Yeah.
And I'll leave it at that. Yeah.
All right.
Yeah. I would definitely like to stay in touch in terms of, I mean, one, I'm going to follow up with you this weekend. Just the overview that you have. I'd really like to put you in touch with Pedro.
Yeah.
And and use some of that for their own kind of summary. I mean, that was just an awesome coverage of the event.
Well,
and
in my best Steve Jobs voice, but wait, that's not all. I'm like, I would love to finish. I want to finish my post, and I would love to share it. I want to get feedback and share it. So like, yes, thank you, because I have put effort into that specifically. Like I want to cover this well, because it's kind of the coolest thing since Princeton and Vision, honestly. Like, and the things that I care about, like it was a great summary of all that, synthesis of all that stuff. So please keep me in touch.
Because absolutely, and it's I mean, one of the reasons why I wanted to drop everything and come for such a short event is that the mission statement that I was given at Frontier Tower, if you read the Neurotech, it's like, I don't know. So actually, my floor is called Neuroscience Tech and BCI, but the actual description of it is much more, augmentation. It's much more cognitive augmentation focused, and so it was. I mean, I loved the Philosopher-Builder part, just because I'm a Johnny. I mean, I'm a St. John's College guy, so it's just like sure. that's at best the only way we can describe ourselves as graduates of St. John's. But the mission was very, very aligned with with what I was given, and like I said, I'm familiar with so many of these orgs that I've only learned about recently, but I would like I'd like to engage with more, and so Echolopto is one. 517 just gave as funded some stuff here for us.
I'd really like to talk more about 517 and Harry, because there was sort of the missing. I had really I heard about the dinner with, or the breakfast with Harry or something Sunday, and I really wanted to go to it. And it was like comic. So many things kept happening that I didn't get to. So that was like the biggest miss for me, was that. So more about that later for sure. And like anything else on these topics that we can talk about. And I do see, even not knowing as much about Frontier Tower as I could, but like knowing you and other stuff, like I see not the roots, but like I see where things can go, and I'm excited about them, and I hope you get to do what you want to do there.
Yeah, for sure. I mean, as well as what are the issues? So Elliot Roth, who leads biotech floor, was brought down to Prospera to potentially build a biolab there, and so I can tell you both, like good things like that, as well as they had money to fly people like Ed Boyden down and things like that. At the same time, unfortunately, nothing was eventually built there,
right?
And they had a huge number of problems. And to your point as well, which is something, I'm surrounded by a bunch of people who I'm not necessarily politically aligned with, but when it comes to the arguments around what the special economic zone is trying to change societal incentives.
Right. Yes.
And I want to say more than just economic incentives, because again, it was a lot like at least the arguments that I hear are a lot about regulation.
Right. Yes.
And you know, and again, it's like it's one of these times where I think what philosophy brings is not the ethics, but is actually the appreciation of complexity and and our interconnectedness. You know, against this like, if things are just cheaper, if there are less rules, that like magic will occur.
Right. It does sort of,
You know.
there's a sort of, I actually think, and part of what I'm trying to write more about in a very particular sense, I think good philosophy in that sense, particularly in the context you just said, I think good philosophy, good ethics is actually being really sober, like actually connecting. Hey, like you said, well, like bring real complexity as opposed to, geez, here's some existing metrics that are empirically, like, we can fucking calculate that. Excuse me. We can calculate that. So let's do it, man. Let's just optimize these couple of variables. We got it. You know what I mean? Like I think philosophy, when it's done really well, in an applied context, illuminates and I'm borrowing language from something entirely else, that I'm not related to this, but it will bring the latent, the hidden, the non-obvious things to the front. And at its best, when it's handled the right way, will force people to deal with the agency and recognize the choice and the problem space. When you put pressure on the choices and the problem space and articulating them, and not just straw manning or trickling it down into, well, that's all great, but here's this number that we need to care about.
Yeah.
I think that's very, I agree with that very much.
Yeah. So anyway, I just wanted to, say like, yeah, thank you so much for the overview. I wish I'd been there, but you gave me a great surrogate experience, and like, yeah, I think there's a lot of value to be found in really engaging with these groups, so yeah, so I still love to strategize just about how best to do that.
Absolutely. Well, that's that's becoming like an increasing focus of what I'm trying to do, both like the practical, and then I actually want to do, really shorthand, I want to go do a PhD in some of this. I don't think it really exists. I don't know that I want to make a PhD. I don't know I want to go through the process of finding a school, institution, interdisciplinary, making whatever. But like, there's rigor and development of how does one, like, I want to get at the theory of how we do this stuff, no less. And that's important, but like, it's just as important that the literally engaging, like, that's all nice. I want to do both. I want to do the broader high level vision strategy, because I think that's so missing right now. Like I didn't say this, but like the imaginary conference that I talked about has the other component is, how do you synthetically decide synthesis that we talk about here, and strategy, like what do you do, like where do you try to go at like the actual broader level, plus all the nitty-gritty stuff that we're talking about here. So more about that later, but like, yeah, please, let's talk about this and do stuff. Like, there's stuff here, like, I feel like, okay, like, there's sort of the San Francisco forever, Silicon Valley stuff, Bay Area. And I know what was so good about this conference for me is that it surfaced a lot of the context I'd really like to have here, even if a lot of them are going to San Francisco. It just like, I got a little better foothold in a real value a community of value to me here. So I'm happy to do more in those spaces.
Yeah, yeah. Well, and like you said, like the good thing being that, the good thing being that they're coming here, and so yeah, let's try and let's try and use all that energy and excitement to find some projects, or find some or set some topics to be discussed and fleshed out. Because the other thing that Frontier Tower has given me experience with is really opening up the number, or getting to meet and greet with all the hacker houses,
Right.
and kind of associated communities. Now, some of these aren't as some are connected to more established organizations like Nucleate, for instance,
Right.
which is a kind of I see some overlap between Neurotech X and Nucleate, except Nucleate being for biotech, but again, it's like would like to think and talk more about how best to engage with these groups, and like it's the kind of things that they would be interested in building projects around. That would be of interest.
Absolutely. And I appreciate talking about that. I realize Bradley probably wants to go.
Definitely
about all this stuff. So
All right. So that's all for today. Thanks for the discussion on this stuff. Thanks, Jesse, for presenting. And see you next week.
All right. Take care, everybody. Congrats to these.